Hello, my dear friends. Welcome back to our YouTube channel. Today we're going to discuss about what is platform independent and JDK, JVM, JRE and JVM architecture. I hope you will definitely enjoy this video. So without any further delay, let's get started. Now the first question is, what is platform independent? A programming language or technology is said to be platform independent if and only if which can run on all available operating systems with respect to its development and compilation. Java is a platform independent programming language because when you install JDK software on your system, then automatically JVM will installed on your system. For every operating system, separate JVM is available which is capable to read the .class file or bytecode. When we compile your Java code, that .class file is generated by Java compiler. These codes are readable by JVM and every operating system has its own JVM. So JVM is platform dependent, but due to JVM, Java language is become platform independent. Point to be noted. Java is a platform independent, but JVM is platform dependent. Here is the diagram that shows the functionality of platform independence. Now here is the source code, and then the source code is converted into bytecode with the help of Java compiler. Then this bytecode is taken by these different JVMs such as Windows JVM, Linux JVM, Apple JVM, and after that this JVM runs this program into these different operating systems. That's how the functionality of platform independence works. Next one is JDK, Java Development Kit. The Java Development Kit is a primary component. It physically exists. It is a collection of programming tools and JRE and JVM. Here is a diagram that shows the JDK. Next one is Java Virtual Machine. Java Virtual Machine is a software. It is a specification that provides runtime environment in which Java bytecode can be executed. It not physically exist. JVM are not same for all hardware and software. For example, for Windows operating system, JVS is different, and for Linux, JVM is different. JVM, JRE, and JDK are platform dependent because configuration of each operating system differ, but Java is platform independent. Here is a diagram that shows the functionality of JVM, how JVM can use this. Okay. Next one is JRE, Java Runtime Environment. The Java Runtime Environment is a part of the Java Development Kit. It contains set of libraries and tools for developing Java application. The Java Runtime Environment provides the minimum requirement for execution a Java application. It physically exists. It contains set of libraries plus other files that JVM uses at runtime. Here is the diagram of JRE, which contains JVM and set of libraries, example .rt, .jar, etc. and other files also. Next one is JVM architecture. JVM, Java Virtual Machine, is a software. It is a specification that provides runtime environment in which Java bytecode can be executed. Here is the Java JVM architecture that shows in the diagram. Now before goes deeply into the JVM architecture, we have to know about the operations of JVM that performed by it. JVM mainly perform following operation: allocating sufficient memory space for the class properties, provide runtime environment in which Java bytecode can be executed, converting bytecode instructions into the machine level instruction. So these are the operations of JVM. which is performed. Uh, Now the first thing is of a JVM architecture is a class-loaded subsystem. Class-loaded subsystem will load the .class file into the Java stack, and later sufficient memory will be allocated for all the properties of Java program into the following 5 memory location. These are heap area, method area, Java stack, PC register, and native stack. Let's discuss each of them one by one. Heap area, in which object reference will be stored. Method area, in which static variable, non-static, and static method will be stored. Next one is Java stack, in which all the non-static variable of class will be stored and whose address referred by object reference. PC register, which holds the address of next execution instructions. That means that uses the priority for the method in the execution process. Next one is native stack. Native stack holds the instructions of native code other than Java code. Native stack depends on native libraries. Native interface will assess the interface between the native stack and native libraries. And the last thing is execution engine, which contain interpreter and JIT compiler. Whenever any Java program is executed at the first time, interpreter will come into picture, and it converts one by one bytecode instruction into machine level instruction. JIT compiler, just-in-time compiler, will come into picture. From the second time onwards, if the same Java program is executing and it gives the machine level instruction to the process which is available in the buffer memory. Note: the main aim of JIT compiler is to speed up the execution of a Java program. This is very important. Now the question arises, what is JIT and why use JIT? JIT is a set of programs developed by Sun Microsystem and added as a part of JVM to speed up the interpretation phase. In the older version of Java, compilation phase is so faster than interpretation phase. Industries has complained to the Sun Microsystem saying that compilation phase is very fast and interpretation phase is very slow. So solve this issue, Sun Microsystem has developed a program called JIT, that is just-in-time compiler, and added as a part of JVM to speed up the interpretation phase. In the current version of Java, interpretation phase is so faster than compilation phase, hence Java is one of the highest interpreted programming language. So friends, that's all for today's topic. If you are new to our YouTube channel, don't forget to subscribe and hit the bell icon for upcoming videos. Till then, stay tuned with us. Thank you for watching.